Power supply. In this video, we are going to see the internal functional blocks of power supply. Circuit board of power supply. Step-down transformer. Bridge rectifier. Filter. Regulator. The operation of the power supply by its internal circuit is shown. Linear mode power supply. In this video, we are going to see the internal blocks and the function of linear mode power supply. The linear mode power supply consists of step-down transformer, bridge rectifier, filter and regulator. An AC input is given to the step-down transformer. The signal is rectified by the bridge rectifier circuit, filter circuit to remove the ripple component, and regulator circuit gives the regulated DC signal as output. Thus, the regulator, that is constant DC output, is getting from the DC power supply. The input and output waveform of different circuits are shown here. Switch mode power supply, SMPS. Let us see about the switch mode power supply. The switch mode power supply is used in computer. The switch mode power supply, SMPS, is an electronic power processing unit that has a built-in switching regulator. It converts the unregulated AC input from the mains or DC input voltage to a regulated DC output voltage, which is given to the computer peripherals like CPU. This is SMPS. It finds an application in laptops, scanners, mobiles, zip drives, hubs, printers, TV receivers, computers, VCRs, and so on. SMPS has several features of switching regulators: high conversion efficiency, light in weight and compactness, electrical isolation of load from source, lower ripple, provides several isolated outputs from a single voltage input. The difference between the linear mode and the switch mode power supply is shown in the table. Application of rectifier in power adapters. In this video, we are going to see about the use of rectifiers in power adapters. The function of the rectifier is used to convert AC current to DC current. Many electronic gadgets we use in our houses require DC power. For instance, laptop, mobile phone, computer, etc. require DC power to operate. But in our homes, we get AC power supply. Therefore, rectifier is required to convert AC power into DC power. Application of rectifier in UPS. The purpose of rectifier in uninterrupted power supply, that is UPS, is shown in this video. In computer and electronic system, loss of power will cause the irretrievable loss of data and damage the system. To avoid the loss of data and damage of the system, an uninterrupted power is used during the time of power failure. This is the internal circuit board of UPS. The highlighted area is the rectifier section. This is the block diagram of UPS board. The AC main supply is given to the rectifier. The rectifier is used to convert the AC voltage into DC voltage. Circuit connection of half-wave rectifier. In this video, we are going to see the breadboard connection of half-wave rectifier. Primary winding of the transformer AC supply is given to the primary winding. It is the step-down transformer. Secondary winding. The low voltage output from the secondary winding of the transformer is given to the half-wave rectifier circuit. Here, RL is resistive load. The half-wave rectifier is used to convert alternating voltage or current into pulsating voltage or current for one half cycle period of the input cycle. Diode, resistor, rectifier output. The input signal and the rectifier output signal are shown in the CRO display. Half-wave rectifier. In this video, we are going to see about the operation of half-wave rectifier. A single diode acts as a half-wave rectifier. The AC supply to be rectified is applied in series with the diode and load resistance RL. Generally, AC supply is given through a transformer. The use of transformer permits two advantages. Firstly, it allows us to step up or step down the AC input voltage as the situation demands. Secondly, the transformer isolates the rectifier circuit from power line and thus reduces the risk of electric shock. The AC voltage across the secondary winding AB changes polarities after every half cycle. During the positive half cycle of input AC voltage, end A becomes positive with respect to end B. This makes the diode forward biased and hence it conducts current. During the negative half cycle, end A is negative with respect to end B. Under this condition, the diode is reverse biased and it conducts no current. Therefore, current flows through the diode during positive half cycles of input AC voltage only. It is blocked during the negative half cycles. In this way, current flows through load RL always in the same direction. Hence, DC output is obtained across RL. Input and output waveforms. Advantages. Circuit is very simple and occupies less space. Less cost. Disadvantages. Low output voltage VDC is equal to 0.318 Vm. Rectification efficiency is low, 40.6%. Ripple factor is high, 1.21. DC saturation of transformer core results in hysteresis loss and production of harmonics in the power supply. Suitable only for very low power applications. Circuit connection of full wave rectifier. In this video, we are going to see the breadboard connection of full wave rectifier. Primary winding of the transformer, the AC supply, is given to the primary. Secondary winding of the transformer. The full wave rectifier is connected as shown in this diagram. The full wave rectifier converts the alternative voltage or current into pulsating voltage or current during both the half cycles of the input signal. There are diodes and resistors. The input signal and the rectifier output signal are shown in the CRO display. Working of full wave rectifier. In this video, we are going to see about the working of full wave rectifier. A full wave rectifier is an electronic circuit which converts AC voltage into pulsating DC voltage using both half cycles of the applied AC input voltage. Construction. Full wave rectifier consists of a transformer, two semiconductor diodes and a load resistor RL. The secondary windings of a transformer is center tapped. The two voltages V1 and V2 fed to the two diodes are equal in magnitude but opposite in 180 degrees phase difference. One end terminal A of the transformer secondary is connected to the anode of diode D1 and the other end terminal B is connected to the anode of diode D2. The load resistor RL is connected between the center tap C of the secondary winding and interjunction of two cathodes of diode D1 and D2. Working. During positive half cycle of the AC input voltage, terminal A is positive potential, C is at zero potential and B is at negative potential. This makes the anode of the diode D1 positive with respect to cathode. Now the diode D1 is forward biased and diode D2 is reverse biased. Therefore, the diode D1 conducts and at the same time diode D2 remains non-conducting. During the negative half cycle of the AC input voltage, terminal A is negative potential, C is at zero potential and B is at positive potential. This makes the anode of the diode D2 positive with respect to cathode. Now the diode D2 is forward biased and diode D1 is reverse biased. Therefore, the diode D2 conducts and diode D1 remains non-conducting. Input and output waveforms. Input voltage waveform. Output voltage waveform when D1 is conducting. Output voltage waveform when D2 is conducting. Combined output voltage waveform. Load current waveform. Advantages. High output voltage than half wave rectifier VDC is equal to 0.637 Vm. Rectification efficiency is high, 81.2%. Ripple factor is low, 0.421. DC saturation of the core is avoided. Disadvantages: cost is high when compared to half-wave rectifiers. It is expensive to manufacture a center-tapped transformer which produces equal voltages on each half of the secondary windings. Higher peak inverse voltage (PIV) rated diodes are necessary for the operation, which increases the cost. Circuit connection of bridge rectifier. In this video, we are going to see the breadboard connection of bridge rectifier. The AC supply is given as the input to primary winding of transformer. Secondary winding. Connections are made as shown. Bridge network. Bridge rectifier with 4 electrical arms. Input signal to one of the diagonals. Output signal from other diagonal. The input signal and the rectifier output signal are shown in the CRO display. Application of bridge rectifier in power supply. In this video, we are going to see about the application of bridge rectifier in power supply. This is 5-volt DC laboratory power supply. The internal circuit board of power supply is shown. Bridge rectifier network. The input sine signal is given to the bridge rectifier circuit and rectifier output signal is obtained. Bridge rectifier. In this video, we are going to see about the constructions and working of bridge rectifier. A bridge rectifier is an electronic circuit which converts AC voltage into a pulsating DC voltage using both half cycles of the applied AC voltages. Construction. Bridge rectifier consists of the transformer core semiconductor diodes and a load resistor RL. The AC voltage to be rectified is applied across one diagonal of the bridge through a power transformer. The load resistor RL is connected across the other diagonal of the bridge. Working. When the AC voltage is applied to the input circuit, the end terminals A and B of the transformer secondary becomes positive and negative alternately. During positive half cycle of the AC input voltage, terminal A is positive with respect to terminal B. In this situation, diodes D1 and D3 are forward biased, whereas diode D2 and D4 are reverse biased. Therefore, diode D1 and D3 conduct and a current flows through the load resistor RL. The current produces a voltage drop across RL. During the negative half cycle of the AC input voltage, terminal B is positive with respect to terminal A. In this situation, diode D2 and D4 are forward biased, whereas diode D1 and D3 are reverse biased. Therefore, diode D2 and D4 conduct and a current flows through the load resistor RL. The current produces a voltage drop across RL. Input and output waveforms. Input voltage waveform. Output voltage waveform when D1 and D3 is conducting. Output voltage waveform when D2 and D4 are conducting. Combined output voltage waveform. Load current waveform. Advantages. The need of center-tapped transformer is eliminated. The output is twice that of the center-tapped circuit for the same secondary voltage. The peak inverse voltage PIV is 1/2 that of the center-tapped circuit for same DC output. Disadvantages. It requires 4 diodes. The load resistor and the source have no common point. 2 diodes in series conduct during each half cycle of the AC input. It increases the total voltage drop and losses. Application of bridge rectifier. An application of bridge rectifier is shown in this video. In today's world, most of the electronic appliances need DC voltages from 3 to 12 volts for operation. An adapter is a device which is used to convert high AC voltages to low DC voltage by the help of a transformer and a bridge rectifier. Adapters come in various shapes, sizes and configuration depending on the use. In some cases, adapters are used to provide power to electronic appliances like video games, modems, etc. And in some cases, they are used to charge the primary battery of the electronic device and also act as alternate power source like mobile chargers, laptop chargers, cell chargers, etc.